This conference will now be recorded.
Hi everyone, today I would like to give demo on Synopsys application oriented Tcl. So Synopsys application oriented Tcl. Here I would like to break the Synopsys application oriented Tcl into three words. First is Synopsys. This course will be very useful for designers or students who are planning to work on Synopsys tools or professionals who are already working on Synopsys tools to create their own automation framework. If they want to do automation using Tcl, this course will be very useful. To be frank, even it will be very useful for students or professionals who are planning to work or already working on cadence tools as well. But there are slight difference in commands compared to Synopsys. So if you just able to pick up the right commands in cadence tools, so even it will be useful, even it will be very useful for even the cadence students as well. So to be frank, so though we have mentioned it as Synopsys application oriented, even it will be very useful for students or professional who are working on both Synopsys as well as cadence tools. The next word is application oriented. So here it is not a very generic Tcl training. Here we are not, here we don't concentrate much on a simple programs like uh, uh, writing a program or script or to get some prime numbers between 1 to 50, or we will be doing a lot of like doing the bubble sort operation or whatever. So here actually we are calling this as application oriented because here we will take a design, and we will try to create our own automation framework uh, to automate our designs as well as to automate our tools on specific designs which we encounter in our day-to-day life. So being professionals or being VLSI students, we have to work on tools, VLSI tools, and we need to automate on the tool platform, right? So that's why we are calling this as application oriented. And Tcl, as you know, Tcl is basically a scripting language, and yeah, usually we call it as TCL, or we can call it as Tcl. It's tool command language. Yeah. This demo will cover extensively the contents which we are planning, to teach in our regular course, the Tcl course. Anyhow, we will be understanding the things, especially on syllabus as well as the course plan in further slides. The goal of this training is to enhance the productivity with Synopsys tools through effective usage of Tcl commands. Here actually we are explicitly mentioning the Synopsys tools, but it's not always. So even it will be very useful on cadence tools. If you want to increase the productivity, or if you want to create your own automation framework, and if you have some ideas in your mind, and if you want to do some automation, so this course will be very useful. Yeah, as I told, to make students to create their own automation framework on the tools, which will make our job very easy and effective. This is student driven course. We have a specific applications, scripting applications, as well as the project, and we will teach how to automate the things by taking a specific design. Even the students can come up with their own ideas, as well as the issues which they are facing in their day-to-day life when they work on Synopsys or cadence tools. Definitely we will incorporate those scripting ideas in our course, and we can automate those things. And we are very sure that once you are done with this course, and it will enhance your scripting skills, and you can resolve your issues by your own. Prerequisites. So this course will be very beneficial for students who are planning to work on Synopsys tools like PT, ICC1, ICC2, DFT compiler, or it will be even more useful for professionals who are already working on these tools. Yeah, as well as even the cadence tools as well, like Innovus, Genus, Tempus. Yeah, here even we will expect that you have some decent basics on other coding language. Like we will expect that you know some basics like the control flow commands like if else or continue break, and there'll be some coding basics, right? We will expect that you know those basics. Yeah. Coming to the main slide, what is Tcl or TCL? TCL means tool command language. So it is a scripting language mainly developed for automating the tools and building our own automation framework. So you take any tool, not only the Synopsys or Cadence tools, even ANSYS like Red Dot, Totem. Most of the tools gives the Tcl shell as an interface to automate the tools. Even a lot of mentor tools, they also use uh, Tcl shell. So this is mainly a scripting language. Once you learn this language, you can automate the tools. Maybe some students they work on Redux, some students are professionals, they work on Synopsys tools, some students are professionals, they work on Cadence tools. Once you know how to write your own scripts, right, so it will be very effective, and this language will be very helpful to create your own automation framework. If you take any script, right, Tcl script, the Tcl script mainly consists of three kinds of commands. One is the generic Tcl command, another is the tool specific Tcl commands, and another is the user defined commands. Here I have made this as the red because this is our primary focus. Generic Tcl commands. So if you take the basic string commands or for each, if else, these are very generic Tcl commands. Sorry, generic Tcl commands. So we can execute these command in any platform, either in ICC2 or ICC1 prime time DFT compiler. Any Tcl interpreter can execute these commands. Coming to the tool specific commands, there are certain commands which we have to execute on the specific tools. For example, let us consider report timing. Report timing is a command which we have to execute on either prime time or ICC2. We have to execute only on those tools, right? We can't execute the report timing command, though it is a Tcl command. We can't execute that command in any mentor tools or ANSYS tools or Cadence tools like Innovus. So when we write any script, right, it will have some generic commands, so any interpreter can execute these things. The next one is the tool specific commands. So only the certain tools will execute those commands. So if you work on Innovus or if you work on ICC2, if you want to execute your Tcl script, you have to use only the ICC2 commands, right? You can't take Reddoc or any other commands. Yeah, the last one is the user defined commands. So here we are coming to the Tcl. Here we will create our own procedures. Procedures are basically a function, and it is a piece of code. If you want to execute again and again, right, we will create our own commands. Once you are done with creation of procedure, right, procedure is basically commands, and it will have its own set of arguments. Once you source the procedures, and then every time you can just execute your commands along with the arguments. For example, if you write a small procedure for add with two arguments, like means we have to give two operands. So if we, for example, I have created a procedure with add procedure with two arguments. Basically, they are two operands. So this procedure will do the addition operation of two operands. So once I'm done with the procedure, if I source that procedure, next time if I want to do the add operation, right, just I will give add space two arguments, 2 and 3, so the output will be 5. Here actually we don't work on like the generic applications like addition, subtraction, or getting the getting the prime numbers between so and so specific values. Here we will be creating the procedures on the tool framework. Mostly we will be working on ICC2. There we will create our procedures. Once we source our procedures, next time onward, just you can pick the procedure name, which is basically a command, and you can pass the arguments. Procedure is a very big topic. We would like to cover procedures in detail in our course plan. So just in a nutshell, so we know what you mean by Tcl. The Tcl is basically scripting language mainly used for automating the tools, and if you want to create your own automation framework, it will be very useful. And the Tcl commands will have three types. One is the generic command, so any Tcl interpreter can execute this command. Next one is the tool specific command. So these commands we have to execute on only a respective tools. Next one is the user defined commands. So it is all about creating our own procedures, and we can create our own command. Tcl breakup. Here actually we are breaking the Tcl into three parts. One is the Tcl beginning, Tcl intermediate, and Tcl advanced. In the Tcl beginning, just we will be understanding the basics of Tcl construct. I would like to go in detail actually what I would like to cover in Tcl beginning. Next one is the Tcl intermediate. So here we will be working only on creating the high impact procedures, how to write the procedures. Again, we can write the procedures with non-positional arguments. We can write procedures with positional arguments. We can write the procedures with some default values. There are a lot of ways to write the procedures. We would like to go in detail about the procedures in this course. And the last very important one is Tcl advanced. Here we will be explicitly working on collections, attributes, and filtering applications. So if you take a prime time or ICC2, right? So we have to manipulate a lot of design objects. Now the question is, what do you mean by design objects? Design objects are basically primitives present in any database. If you take any netlist, right, the netlist will have a lot of primitives like nets, ports, pins, uh, timing arcs, power domains. There will be a lot of primitives. Those are basically called as design objects. I would like to cover in detail what you mean by design objects in our regular class. So so the group of design objects are known as collections. So if you take a design object called port, and port has a lot of properties called attributes. Port has a lot of properties. So there are many ways to find what are the attributes associated with each port, and we can do a lot of filtering. So if you want to get only the input ports, or if you want to get only the signal ports, there are a lot of ways actually. You can, once we know the attributes, just we can do the filtering of filtering. If we just work on filtering, right, so we can create a very high impact script. When you combine all these three things, right, so we can make a very good scripts. This is just an overview. Anyhow, I would like to cover what are the, again, the contents present in beginning, intermediate, as well as advanced. Coming to the Tcl beginning. Basically we know, right, the control flow commands like if else, while, continue, break. You can use a lot of commands to control the flow of the script. And also we use math expressions. There is a expr is a command which extensively do the mathematical operations. And I would like to cover the data types in the Tcl, as well as the file IO operations, like how to open the file, how to read the file, how to write the file. These are the important things I would like to cover in the Tcl beginning. This information you will get even in even if you explore, right, in the Google, you will get most of the information. Our actually primary focus, we don't spend much time in this area. Our main focus is on intermediate and also the advanced one. So Okay, I will come to this later. Just to explain you certain things. Anyone know what you mean by grouping, command substitution, and variable substitution? Can anyone tell what grouping is a concept? It is one of the, we call it as the component in the Tcl. Can anyone tell what you mean by grouping? Okay, yeah, just I would like to brief you certain basic things before going into the Tcl intermediate. Yeah, uh, grouping means if you want to convert the number of arguments into a single argument. Here I will give an example so that you will anyhow I will cover this concept in our regular class. Just I'm refreshing some of the concept. So can anyone tell what the puts command do when you do puts VLSI, what it does?
It will print.
It will print, right? Okay, when you okay, so when you use in the next class I will be using the tool. Actually means I will be using the tool to execute these commands. Since it is a demo, I'm running through the slides. So if you use the puts VLSI, right, the output, the VLSI will be clearly displayed in the tool or whatever, wherever you run this command, right? So can you tell what will be the output of the next command? Okay, if you do puts and also semiconductor, what will be the output will you expect here?
Just the VLSI.
Sorry,
VLSI or error.
just do you expect only the VLSI?
Error.
Okay, here actually what happens is when puts is basically a command. Puts is basically a command. I'm seeing some background noise. Okay. Okay, yeah, the puts is basically a command used to print the message. If you want to print any message, right, we can use puts command. It is basically a Tcl command. When you use the puts VLSI, right, you can clearly see the VLSI will be printed on the screen. So when you use puts VLSI semiconductor, you will get error because the puts takes only one argument, which is the message which is going to print. The puts usually take only the single argument, which is basically a message which is going to print. So here the puts, right, this is basically a command. Here VLSI, this is basically a argument. Argument means it is a input. It is input to the any command. So in front of puts, the puts will only expect a single argument in front of that. So here in the first command, right, we have executed puts and VLSI, and it has clearly executed this command, and the VLSI has been printed. So coming to the next command, this command here, when you use puts VLSI and semiconductor, right, can anyone tell how many arguments are here? Here there are two arguments, right? One is the VLSI and semiconductor. Usually the puts will only expect a single argument, but here there are two arguments. That's why it gives an error. What we need to do means, that's why we need to go for grouping concept. In the grouping concept, what happens is, for we will do grouping using two things actually. One, we can use double quotes, or another is we can use flower brackets. When you use uh, uh, puts VLSI semiconductor, and when you use those two words, right, in the double quotes, then what it will do means it will do the grouping, and it will make that as a single argument. So the puts, when it sees, right, it is seeing a certain, it is seeing the VLSI and also semiconductor in a double quotes. it is seeing the VLSI and also semiconductor in the double quote. So here the puts consider this as a single argument. It considers as a single argument, and it will execute VLSI semiconductor. So you will get the output as VLSI semiconductor. So, and coming to the next one, right? Even you can do the grouping of the VLSI and semiconductor. That is basically converting the multiple words or multiple arguments into a single argument. Here also you can do. It will also group the VLSI and semiconductor, and you will get the expected output as VLSI semiconductor. But what is the difference? What is the difference between both? We can use double quotes and the flower brackets for grouping. But what is the difference when we have to use double quotes and when we have to use flower brackets? So yeah, I would explain in the next slide. But everyone understood grouping. What do you mean by grouping? Grouping means like if you want to combine the multiple words into a single argument, right? You have to clearly tell the command that just if you do the grouping, then the tool will take that entire message or entire information which is present in the double quotes or flower bracket, right? Flower bracket. Then it will take that as a single argument, and it will execute the command. Any questions here? I will come in the next slide. I will explain why we have to use where we have to use double quotes and where we have to use flower brackets. I will explain in the next slide. We basically use double quotes and also the flower brackets for grouping. Any questions in this slide?
No.
Okay, anyhow, I would like to explain in detail. I will execute the things in the labs. Don't worry. Just I'm giving some explanation. Okay, here actually now the question arises like where we have to use double quotes and where we have to use double quotes and where we have to use flower bracket. I will just give one example. So there is another command called set. If you want to set any value to the variable, right? Here a is a variable and VLSI is value. So here the set is a command. It is a Tcl command, and if you use this command, right, set a VLSI, then the value of VLSI will be allotted to the a. So when you use puts $a, can anyone tell what is the output you will expect?
VLSI?
No, $A will be printed, not VLSI.
Sorry?
Directly $A, like it will not be substituted here. Am I right? VLSI in the variable A.
No, here what happens is here actually let us consider. I will use like this. So here okay, now let us consider you have set VLSI to the A, you have set semiconductor to the B. When you use puts $A $B, right? So here you will expect the output as VLSI semiconductor. Here what happens is when you use the double quotes, right? Here the substitution will happen. What is $A? $A is basically a VLSI, $B is basically a semiconductor. $A means it is basically in the address, right? What is the content present? So A as a value of VLSI, B as a value of semiconductor, it will get printed as it is. But when you use flower bracket, right? So what happens is it won't allow the variable substitution. So here you will get $A and $B as it is. So here when you use puts, right, so it won't care actually what it will just take whatever you will give, right? $A means it will take $b as a message, and it will go for grouping and it will print as it is. It is basically your call while writing the scripting, right? Whether you have to go for variable substitution or not, it is basically your choice actually. When you use the double quotes, we call this as a, it is basically, we call it as the double quotes as weak, and this is, we call it as the rigid actually. So here what happens is, when you use double quotes, right, then it will just allow the substitution of the variable. So when you use flower brackets, it won't allow this one. It will print as it is. That is the main difference between double quotes and also a flower bracket. It is basically used for grouping, but double quotes will allow substitution and flower bracket won't allow substitution. Okay. The next one is, anyway, we'll go in detail systematically in the from tomorrow. Just I'm giving some examples actually. So coming to the command substitution, can anyone know what you mean by command substitution?
So like in the first example, in the variable 12 will get assigned.
Okay, by seeing into this command, like, will you able to recognize that this is a command substitution? Here we are doing command substitution. Okay, so wherever, when you look into any script, right, so wherever if you see square bracket, there actually the command substitution means we are executing the command substitution. So what do you mean by command substitution? So if you want to execute any command, for example, first I will break this command. Just do expr 5. Anyhow, I will execute this. I will explain everything in the detail in the class. Just I'm giving some examples since it is a demo. So when you use expr 5 plus 7, right, when you execute this command in the Tcl, expr is basically a mathematical uh, command. It does the mathematical operations. So the output is how much? It is 12, right? So now if you want to set, if you want to set 12 to any variable, usually how we have to do? So you can go for command substitution. When you execute expr, this is basically a command, correct, right? Expr is basically a Tcl command. So when you execute, so here expr 5 plus 7, it is, the output is basically a 12. So when the Tcl interpreter sees anything inside square bracket, right, it will understand that that is a command and that will be executed first. So what the Tcl does, the Tcl interpreter first understand that here there is a square bracket, then that is a variable substitution, sorry, command substitution. So it will expect the command has to be present inside this square bracket, and it will execute this command, and the output of this command is 12, and the 12 will be the 12 value will be allotted to variable a. It is to the variable var. You got it, right? So then if you do puts $var, then what will be the output? The output will be 12. So now I will give one more scenario. Like when you use set, just I will call it as like something like variable, and when you use VLSI, can you, what will be the output actually? So in the next command you will use puts $variable. Can you expect what will be the output?
Error.
VLSI.
It's, can you, sorry, come again?
It will be an error.
Correct, it is an error because because here what happens is when you use VLSI, right? So usually what the tool does, this is a command substitution. So so here VLSI should be a command. If the VLSI is not a command, if it is just a message, then it is error actually. When you execute this command, right, then it will it will it will give it as a error. But if you if we create procedure with name VLSI, so then VLSI is command. So what happens is when you create a procedure with the name VLSI, so then VLSI, if you give the procedure name as VLSI, right, so VLSI is basically a command. During that time you can give, because you are creating your own command for VLSI, right? If that is the case, then you can execute this. So whatever the returned value, right, the returned value of this procedure will be set to the variable and you can display that. It is basically you have to, here you may get error, you may not get error, but here the most important thing is if the VLSI is a command, either it can be user defined command, or it can be a tool related command, or it can be a generic command. If it is a command, then we don't end up with error. If it is just a message, right, if it's just a string, then we end up with the error. So the important thing is when you use the square bracket, right, always the command has to be there. That is the important thing. You got it, right? This is known as the command substitution. Coming to the last point, so report timing is a command which we execute in prime time design compiler. In lot of in if you want to check the worst slack in the entire design, right, we usually use a report timing command. So when you can use the tool commands as well as a command substitution in the square bracket. So whatever the output, right, whatever the returned value of the report timing will set to the VAR, and if you puts, right, if you print, then that value will be printed in the terminal. Got it, right? So this is all about the command substitution. So yeah, what is variable substitution? Here if you look into this one, right, it is a combination of both the command substitution as well as the variable substitution. So here definitely this is command, right, because since it lies inside a flower square bracket, this is basically a command. So here on the top of that we are giving two argument, right, like $a plus $p. So output, so here the A will get substituted with 5 and the B will get substituted with 5, and finally the output of this expression is 12, and the 12 will get allotted to sum, and we can print the sum value. So here the variable substitution means uh, here actually we are replacing $a with 5 and $b with 5, right? That is known as the variable substitution. So if you compare double quotes and flower bracket, which will allow the variable substitution?
Double quote.
Double
Yeah,
quotes.
double quotes. Yeah, double quotes will allow the variable substitution, right? So this one actually it is not meant for it is not meant for variable substitution. It is not meant for variable substitution. This is known as the variable substitution. There are a lot of things are there, just I would like to cover in detail. Just I'm giving some of this one, and also coming to beginning this one, right, even we need to understand the data types, file operation. There are a lot of concepts are there. Just I've given some of the concepts in briefly, not in detail, just briefly I have explained. Yeah, coming to the next part, actually the Tcl intermediate, this is the most important thing. So the Tcl intermediate here, actually we will be only uh, working on the procedures. Before explaining this slide, right, just I would like to explain the intermediate is all about procedures actually. Here there are a lot of things are there, like how to write a procedure with the arguments. if you think about the arguments, right, we have, again, we can give non-positional arguments, we can give the positional arguments, we can give the arguments with the default value, and also we can do the arguments documentation. There are a lot of concepts are there in the procedure. Here actually we will spend a lot of time. So coming to the procedure definition, I would explain this, but I will give some scenarios like how the procedure will be useful, and I would like to explain the different flavors of procedure, so that you will understand this slide. So can anyone tell what you mean by procedure?
Procedure are user defined commands. मतलब
Mhm.
making if user make a command, then it will be called as procedure. Like such a, for example, like मैंने report timing एक command बनाया है, and whatever I printed there inside in the report timing, whatever I want in the report timing, then this will be the procedure.
Yeah,
Anything
you are right actually. Yeah, please go ahead, please go ahead.
completed actually.
Okay, yeah. The procedures are, yeah, basically as she told it, the procedures are basically a set of commands. Mainly we will use for reusability and reusability function. Because when you write any code, right, so every time you can't keep on executing that code. So what we can do means we can write our own code and we can create a procedure. It is basically we are creating a command. Next time if you want to rerun the same set of functionality, right, no need to just copy paste the code, just we can make use of that user defined command and we can execute wherever we want. Just I would like to give a small example, you will understand.
This PPT will be given to us in the mail, or
Sorry, can you come again?
is this PPT will be shared with us or not?
Yeah, it will be shared actually. Even the video will be whatever the explanation I'm giving, right? This video will get recorded, and I think even they will share the link of this video, I guess, if you miss anything in between.
Okay, okay.
Yeah, yeah. Okay. So here I would like to give one example. So if you do report timing, right? So just to give some background, report timing gives worst timing report for entire design, right? So yeah, report, if you just execute the report timing, I think some people are from cadence background, just this is not any like the tool means here actually I'm not any since I am from synopsis background, just I am using this. I don't know the command in the cadence, but we can use this, we can use those commands as well actually while writing the script. It doesn't make, actually this is not any the Innovos or PT related training. Here actually we will be working towards the automating the multiple tools, either it can be a cadence or it can be a synopsis. So just I'm giving one example. Here report timing gives the worst timing report for the entire design. So and also when you use the report timing, right, you can use even minus, from, and even you can use to. Let us consider you want to write a procedure. I will give one example. Okay, before going, okay, you know, right, there will be a lot of timing paths. The timing paths will be present in the design. The timing paths can either it can be into reg, or reg to reg, or reg to out, or into out. These are the different timing paths. Don't worry, actually here actually my focus is not to explain this one, just I'm giving one practical example which we encounter in day-to-day life. So there will be a lot of timing path present in the design, and if you want to execute a report timing for any path, so if you take any timing path, right, every timing path will have start point, and endpoint. Can anyone tell what are the start points of any timing path?
Start point are like input and clock port, and end point will be like deep in of the flop and output port.
Yeah, you are right actually. So so if you take any so if you, yeah, these are the four types of timing path, but as she explained, like the start points, if you want to do the timing between any 2 points, right, the start points usually start at the input ports, or it can start at the clock pin, and the endpoints usually at the D pin. So just I would like to explain here. So let us consider this is a register and this is a register. So don't think actually this course will only talk about the timing. Actually, just I'm giving one example. Just to take the context of this example, even we can extend this to PV, prime time, DC, whatever actually, wherever you work, right, it will get fit in. So let us consider this is a simple design. Okay. Yeah. Let us consider this is the timing path. This is one of the timing path, right? So here the start point is the clock pin and the end point is the D pin. So now you have to write a procedure, means you want to write a procedure. So you have to get all the instance pin of this timing path. Here what is the timing path? Here the timing path is, let us consider this is ff1, this is ff2. So here you can clearly tell you are interested in doing, you're interested in getting that the report timing from the clock pin to the D pin. So what you are interested, you should get all the instance pin of this timing path. So here how many instances are there? This is one instance, this is one instance, this is one instance. So here this is one instance. Total there are 4 instances are there in this timing path, right? So what you want, the clock, you want basically the pins of each instance. So you want to write a Tcl script in such a way that the output should be ff1/d, and let us consider this is like ibuff1, this is ibuff2. So the output should be the ff1d, ibuff1a, so ibuff2a, and also ff2/d. So this is the output. You means here you need to write a procedure. You need to write you need to write a procedure. So the output of the procedure should give all the instances input pins as the output. Even if you want, right, even if you want, even you can get even the output pins as well. Just I'm quoting one example. So so here what we will do means, here actually this is the procedure to get all the instance pin for a specified path group, for a specified path. So again, if you take any design, right, the design will have many path groups, right? So we will create our own path group. So here when you do the timing, right, between one path to means for any path, we will get the timing report. But we are interested to get only, we are interested to get only the pins, right, instance as well as the pins here. So what we can do means, just we can write a procedure, we can give any name to write any procedure first we have to start with the proc and we have to give the procedure name. Here we are interested to get the instance pin for any specific path group in the design, right? So here how many arguments you have to give? Here you have to give the path group name, from, and also to. So the path group means there will be a lot of path groups, right? Usually the path group will be decided by the capture clock, or even the user will create their own path groups. So here actually the user is interested to get the instance pins for any specific timing path for any specific path group. So that's why here the user need to give three arguments to the procedure. One is what is the path group is interested in, and what is the from is basically a start point, and to is basically end point. And this is basically a procedure name, and they need to write the body. So in body we have to write the logic, like how we can write this procedure, that I would like to explain in the main course actually. So here let us consider we have written a procedure with the procedure name. We can give any name, and definitely this procedure requires the three arguments, right? One is the path group, from, and to, and body. So let us consider we have written a procedure, and once you are done with the procedure, right, when you source that code, then the command will be created. Then this is basically a command. If you look here, right, this is the name of the procedure, right? So next time what you need to do means, just you need to give the procedure name. This procedure name is inst pin path group, and here this procedure will expect three arguments, right? One is the path group, and another is from, and another is to. So it will execute three arguments. So now this structure is right. So if you look into the output, right, so the output will give all the instances which are present in the timing path from this clock pin to this D pin for this path group. So it will give all the instance pins. Just I'm quoting one example. It is not only the instance pins. If you want to do any applications, you can do. This is the structure of the procedure. First step is we can write the procedure, and we can set the arguments, and we have to write the logic. Once we are done with the procedure, right, every time just we can use this procedure, and we can followed by the number of arguments. Next time if you want to get all the instance pins for the different path groups and for different start and end points, right, the procedure name will remain same. Just you can just keep on changing the arguments. But actually if we think, actually if we don't have procedure, so every time we have to keep on writing the code, right, for the different path groups, different start points and end points. That's why once you write the procedure in a very generic way, and if you give some arguments here, right, so once we are done with writing procedure, right, you can use the same set of commands, and for the different path groups the input means the start point and the end point, and we can get all the relevant information. This is some basic idea about the procedure. But here when you here actually I have quoted here actually the procedure example and also the positional argument. But if you look into the arguments, can anyone tell how many arguments we are giving to this procedure?
Three arguments.
Three arguments, right? Okay, now this is basically a procedure name. Here we are giving three arguments. uh, Here three arguments. One is the path group, another is the from start point, and another is to end point. Okay, now let us consider we have written a procedure and the body we have written. uh, Now I will execute. But here here we are giving exactly the arguments, right? One is the reg to reg, and we have given the start point and we have given end point. Let us consider I will execute the procedure something like this. Okay, so do you think that can I expect here what I did? Just I have changed the ordering, right? First I have taken start point, and then I have taken two, and then I have taken path group. So I reshuffled the arguments. Do you think that this procedure will work now? Means this command will work?
No, sir.
No.
No.
So here when you execute this command, right, what happens is this command may work or may not work, but the problem is definitely we don't get the expected output, because here when you looked into the argument list, right, the first one is the path group, the second one is the from, and third one is the to. So whatever the first argument you will pass in front of the procedure, right, it will always consider that as a path group. So here, according to the procedure, the path, what is the path group? The path group name is this one. But if you look into our design, this is not the path group, right? Here we are expecting this is from. But here actually, since we are giving it in the argument first argument place, that's why it will take this as a path group, and this as a from, and this as a to. Definitely we don't get any expected output. That's why here the important thing is, when we write the procedure like this, right, so what happens is we have to give the arguments in a very systematic way. Means we have to maintain the position. While here while writing the procedure, right, you will clearly define, means how many arguments you have to give. So there, here you will maintain some order, right? While executing that procedure, you have to maintain the same order. If you don't maintain the order, right, then definitely you will end up with the issue. That's why we are calling this as a positional arguments. Positional arguments means you have to maintain the position of the arguments in front of procedure. uh, that is the thing. Think in a realistic scenario, like sometimes you have written a very big procedure and it has like 50 arguments. It will be very difficult to give the exact ordering, right? uh, for the user, first we have to give this, second we have to give this, third we have to give this. It will be very difficult actually. But when you execute a simple and very like small procedures, right, you can go to this method. But if the procedure is very big, and if the number of arguments is very, if the number of arguments are argument number is very high, right, it will be very difficult for the end user to use this command, this procedure. And another thing
Excuse,
is, yeah,
excuse
go
me,
ahead
sir.
please.
Sir, if we
Yeah.
want that the path group will be into out, and some from and some to, then
Hmm.
every time we have to change these arguments to run the proc.
No need to change, the proc. For example, in your case, right, what you need to do means, okay, you want one
Sorry, I'm mistaken. Every time we have to change the arguments, not the proc body, but
uh-huh.
arguments must be changed for different like path group and different endpoints.
Correct. Here actually, if you're this procedure will remain same, you no need to touch. If you're interested in into out path, right, just you can give just your respective path group, just you can give from and you can give to, then you will get the output.
Okay.
Yeah, here actually that is the main advantage of the procedure actually. So this is very generic, and just you need to only play with the arguments in the path group, right? You can give any path group in the design, you can give any start point in the design, you can give any end point in the design, you will get the respected output. You no need to again do any changes in the proc. That's why the proc is very generic. Just it will just you have to change the arguments actually based on your requirements.
And if we want something else, like other than path group and endpoint start point, something else I want to so may I
Yeah,
add?
yeah, whatever you want to write, right, put everything in the argument list and you just execute that procedure. Here just I'm quoting some example. It is not like only you have to give these many arguments. You, based on your requirement, you can give any number of arguments. Even sometimes it can be optional arguments, anything actually. Just you can give the arguments, and based on that you can use.
Okay, thank you.
Okay, so here actually in the positional arguments, right, what happens is you have to maintain the position. But if you look into the realistic scenario in industry, what happens is there will be dedicated methodology groups, and they will write a lot of scripts, and the end user need to use that script. Otherwise, what, that is one case. And another case is, let us consider you have written a script and you will send that script to one of your colleague. So your colleague should understand, he should execute your script very easily, right? That that is the main import. That is the main thing actually. You need, when you write any script, right, when you pass that script to any of your friend, your friend should easily understand what the script does and how many arguments are there in the procedure and how to execute that procedure. This information your friend has to understand without your much explanation. That I will tell actually how to do that. But if you look into this one, right, this is a bit problematic. If if you write your procedure and if you execute, right, then you will be knowing actually what is the order and you can mention that order. But it will be very difficult for other users to execute this procedure because we have to maintain the proper order. Okay, coming to the next one, right, now how to overcome this. I'm just giving the different flavor in the next step, right, still it will be very handy. So now how we need to write the procedure? We need to write the procedure in such a way that the user should not maintain any order. He can give any order, but he has to get the expected result. That's why we call that as a procedure with switches. We call it as non-positional arguments. In non-positional arguments, what we will do, we will give the procedure name and we will create the switches. If you look into any tool command, right, every tool will have lot of switches. Here I'm creating, here there are three arguments are there. Parallelly we will create the three switches. One is minus path underscore group switch and minus from switch and minus two switch. So here when you use minus path underscore group switch and in front of that if you give the path group, right, the tool will clearly understand that okay, whatever the reg to reg, right, this is the path group. So minus from and in front of that it will give anything, right, it will give that as a from. And then minus 2 in front of that if you give anything, it will understand that as a 2. Even you can execute like this. So here you can, okay, if you execute like this, do you think that this command will work?
Yes.
It will work, right? Here why means here actually the tool will clearly understand that in front of minus path group, right, whatever it is, it will understand that that is the path group. In front of minus from, whatever it is there, right, it is basically a from. That's why you can reshuffle, actually you can reshuffle and you can easily execute the command. But still this has some problem. Can anyone tell actually? Definitely the first procedure, right, whatever we have written, that is okay, the output we will get the same output, but the scalability are like the way we execute, right, so it will be, means the way we execute, right, it will be very difficult because we will be writing lot of scripts, right, so it will be very difficult for us. In the first case it will be very difficult to for us to maintain the order. In the second one it is comparatively too easy because we no need to maintain the exact order. But the problem is when you write any procedure, right, when we write any procedure, right, first we have to understand how many switches are there, in the procedure. That is the most important thing. I will come to that point later, but comparatively this will solve most of our problem actually. So here we no need to maintain any order, just only we have to make sure that we have to give the right switch. In front of that we have to give the argument value. But here the question is like, how we will know that there is a from switch, how we will know that there is a to switch, how we will know that there is a minus path group switch? That is another thing, right? So that's why what we need to do means we have to write a procedure. When we write any procedure, right, we have to maintain a proper documentation inside the procedure so that the end user will clearly understand what exactly that procedure does. So we know when you take any synopsis, when you run any synopsis tool, right, there are two commands. One is one is the man command. Okay, so we know actually if we want any detailed information about any command, right, So either you will go with the two options. One is you can go with help minus v, and you can give any command name, and it will give. Okay, before that, actually, can you tell what is the difference between these two things? What happens when you do help minus v report timing? What happens when you do man report timing? So when you use when you use help minus v on any command, right, when you execute this, so you will get what is the function of that procedure, means what that procedure does, and it will give how many arguments you have to pass to that procedure, means how many switches. It will give all the switch information. But when you use the man command, right, the man is a very detailed command. It is kind of manual. When you use the man, and if you give any command, right, any tool command, it will give a very detailed report. It is basically your choice. If you want only the procedural information as well as the switch information, right, you can go with help minus v, and if you want very detailed information, you can go with man command. So here the question is, when you write your own procedure, right, the means when you write our own procedure, then it is like we are creating our own commands, right? So if you send your procedure to anyone, once your procedure is sourced in the Tcl shell, right? So if anyone does the man operation or help minus v operation, right, do you think you will get all the required information that what your procedure does and how many switches your procedure has? No, right? Because there actually you are not taking care of anything, just you are writing a plain code, and you are just writing a plain code, and once you execute that code, right, then you can reuse as a command. But the most important thing is you have to maintain a proper procedural documentation in such a way that once you are done with the procedure, when you give the procedure to anyone, if you source that procedure, and if that end user, if it does help minus v, and if you give your procedural name, it has to give this information. So if you take our same procedural example, it has to display something like this. This procedure gives all the instance pins from the start point to the end point for a specific path group. Okay, since I'm an end user, so then I will understand that, okay, this is the procedure he or she has written, and okay, this is the task it is doing. Okay, my next question is, how many switches I have to give? So it will clearly tell that like this. So it will display all the switch information, like minus path group, minus to group, and minus from group, and it will clearly give the explanation. Minus path group means specify the path group, minus to means specify the start point, minus from means specify the end point. Okay, now the user will clearly understand that this is the main task of the function, and here there are three switches, and here there are three switches, and it will clearly explain what is the it will clearly explain that what is the how to use each switch. It will clearly give the information. Then the end user, he don't do anything actually, just he will use the procedure name like this. He will use the procedure name. Here only it will give some information, right? Definitely will use the path group. Just even if you use minus, if you use minus and p and tab, right, it will get auto completed. Actually it will get auto completed. It will get auto completed. You can give the path group, you can give the path group, you can give any path group, then you can give two, and you can give any two, and you can give this one. So this is the very right way of writing the procedure. We have seen the three different flavors. Still there are a lot of things, actually a lot of mistake usually the people will do. But if you write a procedure with the if you write a procedure in a non-positional argument style, as well as if you do the proper documentation, right, so then it will be very useful for the end user. You may get a lot of questions like how to do this. So I will explain like how to do a procedural documentation, as well as how to first we can start with the positional style, then we can move to non-positional style of writing the arguments, then we can even work on how to do the procedural documentation, so that it is a very complete style actually. When you write this procedure, right, when you give this procedure to anyone, then clearly you will get all the required information, the switch information, everything. Even on the top of this, right, even if you want to convey any other information like author and whatever, and even you can convey this information so that the end user won't depend on you. So it will be very useful, because sometimes what happens is you will write a procedure, you will use for your current sake. After 3 years you will open your procedure only, then you don't understand what it is doing, and what arguments you need to pass, what switches you need to pass, you only don't understand. That's why if you make a proper procedural documentation, right, you can just you can do just the help minus v on your procedure. So it will give all the relevant information, whatever the information the author needs to convey to the end user, just you can write all those relevant information. Okay, we will be working, this is not only these things, we will be taking lot of real-time scenarios, and we will be writing lot of procedures, and this is the one of the thing I would like to cover. Okay, then before jumping into the third Tcl advanced, so can anyone tell what is the difference between the command output and also the command returned value? Can anyone know actually what you we use two words actually. One is the command output and another is the returned value.
The return value is if the if your logic went fine and you get the desired output, then it will return 0. Otherwise, it will return 1 or something like that.
Correct. Yeah, you are right actually. So let us consider. I will just explain on the report timing. The report timing, we know it gives the worst timing path in the entire design. The report timing, if it is successfully executed, right? One is once you run the report timing, if you have loaded all the required input collaterals to any tool, right, then you can do the report timing, and the report timing will give a lot of information, like it will give the data arrival path, it will give the data required path, it will give the slack information, it will give a lot of information. And in the last line, right, it will give it as 1 or 0. If it is 0 means the command is not successfully executed. If it is 1 means then that is successfully executed. So the command output means whatever the output which the report command is dumping, right, that is known as the command output. when when in the last line, right, it will show either 0 or 1. If you execute any command in the last line, you can see either it will show 0 or 1. That is known as the returned value. So when you do like this, a, so always the command substitution, right, always the command substitution will give the returned value. When you do like this, set a and report timing, so the report timing, right, here if you look into the report timing returned value will be either 0 or 1. But if you look into the command output, right, so the command output will have a lot of information, like it will have the clock information, and it will have the start point, end point information, it will have all the instances present in the data arrival path, data required path, it will have the slack information. So all info, we call it as the command output. But always you remember, when you go with the command substitution, so when you do the report timing, right, always it will give the returned value. You can't when you set a to report timing, right, you can't expect this information. So only you can get either the report timing is executed successfully or not. If it is executed successfully, then the command output will be 0, sorry, 1. If it is not executed successfully, then the command output will be 1. So if you want the complete command information, right, so you have to use redirect command. This is a very useful command. I would explain this command in our regular sessions. Actually, it is a very awesome command. And so if you want the complete information, right, if you want the complete command output as well as the return value, right, then you have to go with the redirect command. So it will be a very useful command. But if you're interested in only the returned value, right, then we have to go with the square bracket. So don't worry much, anyhow I will be executing, I will be showing in the labs actually, like detailedly, don't worry. But here the main difference between the command output and return value is when you execute any command, right, the command will give some kind of information, as well as the command will clearly tell it as 1 or 0. So always we take the 1 or 0, whether it is executed successfully or not, that one we call it as the returned value, and whatever the information it will give, right, that we call it as the command output. So if you want, if you're interested in only the returned value, right, so you have to go with the command substitution, and you can do like this. But if you're interested in the command output as well as the returned value, right, we have to use redirect command. Redirect command, actually either you can redirect to variable, or you can redirect to the file. There are a lot of things are there. I would like to cover this redirect command in detail, uh, detail in our regular classes. I don't know, I might be going a bit fast because I want to give you the flavors of the things which I would like to cover in the in our next course of time. Actually, that's why I'm going a bit fast. Anyhow, I will be re-explaining most of the things in a bit slower pace, and even we can parallelly do the labs, right? You will do some mistake and you will correct yourself, so definitely it will be very useful. Now I want to rush in because I want to cover some other things, so that you will get the feel actually what are the things you going to learn in the course of time. Okay, now
Uh, Excuse me,
okay,
sir.
yeah, please go.
Before that, we will learn file handling. Like it is very useful actually.
Yeah, we will be
Uh,
doing everything actually. See here, if you look into the Tcl beginning, right, here actually the file operations are there. Actually means how to open the file, how to, I will cover everything, don't worry. But this one actually already you know the things, right? Now whatever I'm explaining, like procedure and also the collection design objects which I'm going to cover, that will be new actually. Don't worry, we will be doing from the scratch. Even we will be working on the file operations as well, because this is the most important thing, right? How to read the file, how to write the file, like how to set the pointers. We use a C command and also the tell command to set the pointers and all those stuff. Actually, we will be extensively working on even the file IO operations, which involves the file handlers as well.
yeah. Okay. Thank you.
Yeah, don't worry, we don't miss anything. But our concern is you have to learn the new things in these 6 weeks actually, because most of the things, right, you will get in the Google, like file handlers and all those stuff. So I will be explaining all those stuff, but the main important thing is we have to work more on the procedures, and also we need to work extensively on this is the main actually, the day-to-day, right? If you work on the tool, this will be very useful. So we understood what are the things we are going to cover in the beginning, and we understood like how to write the procedures and all those stuff. And now the important thing is the Tcl advanced. So in the Tcl advanced, right, so I would go one by one. So first we have to understand what you mean by the design objects, and we have to understand what is the collections. And in the collections there are a lot of things. So I will go one by one, actually we will understand. So can anyone tell what you mean by design objects? So if you take any tool, right, so either you take Cadence tool or Synopsys tool, any tool, so definitely you will be working on the database. If you're working on the implementation side, like ICST or Innovus, so it is a database, right? Basically it will have, that database will have a lot of design objects. The design objects, it can be clock, or it can be port, it can be pin, net, timing, or library cells. There will be hundreds of design objects. We usually call each entity as a design object. If you look into any design, right, the design will have ports, the design will have pins, the design will have nets, the design will have timing arcs, library cells. There will be a lot of information. So each entity, like we call it as the design objects. So what are collections? The collections are the group of design objects. Let us consider you will do all underscore clocks. So what all underscore clock commands does? So if you do all clocks, right, you will get collection, you will get all the clocks information in the design. If you do get clocks, the get clocks also gives all the information about the clocks. It will give all the clock names. The question is when we have to use all, when you have to use get, that is the later part. I will come to that. But when you use all clocks or get clocks, right, means all all underscore something or get underscore something, when you use that command, right, it will give the information in the form of collections. So collections are basically the group of design objects. So when you execute this command, right, you may get something like this: select like 10. I don't know whether you have observed or not. This is basically a collection. So this collection, this is basically a collection. This collection will be having lot of clocks. So now how we have to handle, now it is basically a collection handle. It is something like this. So the important thing is how we need to operate this file handlers. So this is basically collection handlers. So we will learn in detail about how to handle the collection handle. And also there are a lot of collection commands. You can't use puts command, or you can't use those kinds of commands in like list command. You can't use normal commands on the collection handles. So we have to use a collection specific commands, then only you will get the right output. For example, if you want to display all the content inside this collection, right, we have to use query objects. That is one of the collection command. So here we will be understanding what are collections and what are collection handles, like what are the collection commands, how to count the collections. To count the collections, right, we use the size of collection, like how to use the loop operations for the collections, like how to append the collections. Like we will be working extensively on the collections. So if you do the automation stuff, right, 99.99% you will get everything in the form of collection. Just you need to handle the collection only. It's very less that you will get like the list or string. In the very rare case you will get that, but most of the information, right, in the Synopsys tool you will get the output in the form of collections only. So we have to be very good at handling the collections. That is the thing. So the next important thing is, like, once once we know what is collections and what is design object, now we need to do, again on the top of that, we need to do the filtering operations. So filtering and sorting operations, what do you mean by that? Let us consider there is a small scenario, like you want to find how many flip-flops are there in the design. Do you think that we need a very big code to get this information? Can anyone tell how to do that? Okay, you might be working on any tool. Either it can be flip-flop, it can be prime time, design compiler, Reddoc, or whatever. You want to get all the how many flip-flops are there in the design. So how to do that? So the command is, we have to use get cells. When you use get underscore cells, right, get underscore something means it is basically collections. So get underscore cells is a collection command. Star means it can be anything. So you need to use the filter operation. So if you use is sequential is equal to true, right, then it will give the collection of all the flip-flops, the collection of all the cells which has the attribute of is sequential, which is set to true. Then if any cell has is sequential is set to true, means definitely it is a flip-flop, right, because it is a sequential cell. Like that we have to write. But here if you just break down this command, right, here there is a get cells, here there is a minus hierarchical, here there is a filter, and here there is a is sequential. But you can ask, like, how I will know that I have to use minus hierarchical, and when you come to the filtering operations, right, then how I will understand that I have to use is sequential only? There can be something else, right? There can be something like is underscore seq will be there. So that's why there are a lot of commands are there. I would like to cover in the next like 5 to 6 slides. So when you take any design object, right, here can anyone tell what is the design object? The design object is here cells. The design object is cells. And when you use the get cells, right, that is a collection of cells. So when you use get underscore cells asterisk, right, so you are getting the collection of cells, which is basically a collection of instance. On the top of that, you are clearly telling that you are interested in hierarchical. Means if you mention minus hierarchical, right, it will give the complete hierarchical path. And you can use the filtering operation, means whatever the collection of cells, right, whatever the collection of instances you got, right, you are not interested in all the instance collection. Only you are interested in the collections of instances whose attribute is sequential is basically attribute of that cell which is set to true. Means you are interested in the collection of only flip-flop. So that's why we have to use the extensive filtering operation. So that's why here we have to spend a lot of time to get how many design objects are there in the design, like how many switches we can use, like if you want to do the filtering operation, like how many attributes are associated with each design object. If you take cells, right, so the cell is one of the design object. So get cells is basically a collection. So the cell will have a lot of attributes are there, like e sequential is also one of the attribute associated with the cell. So now the question is, like, you need to understand, right, you need to understand what are the things, like how many design objects are there in design, like, and how many attribute are associated with each, how many attributes are associated with each design object. Here the design object is cell, the get cell is basically a collection, is sequential is one of the attribute. So if you do is combination, that is one of the attribute. So there can be a lot of attributes, right? So how you can get the attributes of these each design object, I would explain in the next one. Don't worry, I'm going a bit fast actually, but actually it will take a lot of time to explain, because uh, I don't it will take some time actually. When we do the hands-on, right, it will be very easy. You can only do, actually you can only come up with the right attribute. I'm very sure that you can just play with these kind of things. I will just show you some of the tricks, like how to, you will get all the information, just you have to pick the right thing, and you need to you need to create your own set of command. Okay, now coming to the things, actually what are attributes. So clock is a design object, right? So clock, net, port, pins, library cells, timing arcs, these are the design objects. So every design objects will have a set of attributes. So if you take the clock, right, the clock will have period, full name, waveform, sources, etc. So like, so every year the question is, like, every clock will have a lot of attributes. So these are the set of attributes. Now you will get some clarity here. So now first the question is, like, first you have to understand how many design objects are there in the design, right? So when you do just help attributes, you will get all the design objects, something like this. So there will be hundreds of design objects, so you will get all the information. So the first question is, if you want to get all the design objects, if you want to get all the design objects in the in any tool, right, primarily synopsis tools, and if you use the help attributes, right, you will get all the design objects. Let us consider you are interested in some port, you are interested in some design objects like port. But the next question is, the first question is how many design objects are there in the design. The second question is how many attributes are associated with each design object. So here, if you look into the ports, right, now the next question is how many attributes are associated with each design object. Now, okay, before going to that, actually you just understand what is the difference between the get underscore and all underscore. So when you use, just you have to understand this point. When you use the get underscore star, it can be anything. Get underscore pins, get underscore ports, get underscore this one. If you are, it can be the all underscore something, all underscore pins, all underscore ports, all underscore registers. So when you encounter any get or all commands, right, the output will be always in the form of collections. So here the question is, what is the difference between the gets and the all? If you use the get clocks, and also if you use the all clocks, let us consider, if you use get all clocks, you will get all the clocks in the design in the form of collection handle. It can be something like this. So if you use even get clocks, you will get clocks, right? Even you will get the same set of you will get the same clock information in the entire design. The question is when we have to use all and when we have to use get. So coming to the so when you use all clocks, right? So definitely it will show something like this: clock 1, clock 2, clock 3, clock 4, ST, RAM clock, PGG, logic clock. Okay, when you use just get clock, right, and when you use all clock, you don't see any difference. But the get clocks has a very good feature, like you can give in front of, you can give the pattern in front of that. So for example, just if you use just if you use clock asterisk, right, it will give the collection. This collection will have only clock 1, clock 2, clock 3, clock 4. Otherwise when you use like this, right, so when you use just ST RAM, then what will be the output? The output will be the collection. So the output will be the collection. It consists of only ST RAM clock, right? So here you can grep. When you use the get command, right, it has a very good features of gripping the things, because most of the time you won't be interested in all the clocks, right? But if you use all clocks, you don't get that option. Actually, all the clocks means it will give all the clocks, but if you use the get clocks, right, you can specifically grip the things based on the pattern. uh, so you can take some specific patterns. On the top of that, you can again set attributes and the filtering application, so that you will get a very exact information what you need. So that is the main difference between the all clocks and the get clocks. Any question in this slide? Don't worry, actually we will be doing a lot of hands-on. Just even if you understand at the surface level, right, that is good, that is good enough. Any of you will be writing a lot of scripts, and I will explain in detail. Actually, I will go in a very slower passion. Just I need to just give some of the information, right? Just I'm going a bit fast. Okay, now yeah, here yeah, we understood. Actually, the gets and the all are basically a collection command, but using the get, right, if you use the get, you can give the pattern, and you can selectively pick the collections, and you can do the operations. But if you use the all commands, right, you don't get that information. So, and this is another the important thing here. Actually, what I'm trying to convey in this demo means I'm giving the different ideas for you. Actually, like what are the different kinds of things we have to consider. Then we can go in detail. Whatever I've explained, right, we can go in detail. But just I'm giving like what are the different aspects are there while writing the scripting, especially when we work on any application tool. So here the most important thing is sometimes we have to link the two design objects. Here let us consider you want to, here there are two design objects. One is the get cells, another is the get nets. Let us consider you want to get all the instances which are connected to a specific net. Here if you use get cells minus objects, and here if you use get nets, and this is basically a net name, what it gives here, this is a get command, right? It will give the set of collections. It will give basically collections of instances which are connected to this net underscore STRAM. So here we are using off object. So off object is a very important switch if you want to link between the two design objects. Here we are linking the two design objects, right? The outer design object we call here, it is get cells, and the inner design object is a get nets. Here you are linking between the two collection objects, two collection objects, right? One is the get cells, another is the get nets. But you are interested in the cells, which are connected to the net like this. So if you're interested in this, if you're interested in the cells which are connected to the net with net underscore STRAM, and it can end with asterisk. Actually asterisk means it can be anything. You will get all the cells which are which are connected to those nets. You got it, right? So otherwise, like, you can do like this actually, get pins. Can anyone tell what this does actually?
It will give all the pins of
Get
this IP
get,
of one cell.
Correct.
get
Here
the
actually,
pins of
here
the
also we talk about the pins and the cells, right? So here what this does is, this is basically the instance name actually. There is a instance called IBUF, but if you're interested to get all the pin information of IBUF, right? Definitely we have to make use of objects, because here we are linking those two things, right? We will be extensively using this command. The off object is a very useful command if you want to link the two different design objects. So here actually the question is, like, let us consider actually you have a net. Net is one of the design object, right? So net is one of the design object. But you want to know how many attributes are there in the net. So then only you can do the filtering operations, right? So there can be like there can be hundreds of the attributes associated with each design objects. So so here actually you need to get all the attributes. Just to go into that, first you have to clearly understand what is design object, what is collection, and what is attributes. Can anyone tell what is design object?
Net pin.
Yeah, it can be anything, right? Pin, port, or whatever. Means it is basically a design entities which is present in the database. What is what is collection? Collection means it is a group of design objects. Okay, then what is attribute? So every design object
For example,
will have attributes. So
length
here
b
actually
box.
here we want to list all the attributes. Here we want to list all the attributes which are associated with the nets. Here either you can use pins also, pins, ports, whatever, so that it will list all the attributes. It will list all the attributes associated with the pins. So the next question is, what we have to do when we get all the attributes? So we understood how to get design objects in the design, and now actually we understood when you use the list attributes minus application minus class pin, right? It will give all the attributes associated with the pin. Now actually if you want to read any then actually you understood. So here let us consider, I will just give, let us consider cell. So it will give lot of attributes. Here one of the attribute here is physical status. It will give lot of attributes. You understood actually. So when you executed this list attributes minus application minus class cell, right, it will give lot of attributes. So one of the application is physical status. So now you want to get what is the every attribute will have a fixed value, right? So now if you do get attributes, and if you give get cells, and if you give I underscore ram, right, if you give the physical status, it will give what is the physical status of this instance. So here there are different things. One is getting the design objects and choosing one of the design objects and getting the attributes, and again getting the attribute value of the each attribute. These are the different things actually. One is you have to clearly understand how many design objects are there in the design. Then you have to, based on your applications, right, you have to pick one of the design object. Then you have to find out how many attributes are there how many attributes are associated with that design object, and then you have to get the value, right, because this is attribute. So here if you use this is a design object actually, collection of design object, and you are interested in this is attribute, but you want the value of the attribute, right? So if you just you want to get whether the IRAM physical status is fixed or not, just you will use the get attributes get attribute, and you will give the get underscore cells, and you can give any cell name actually. So you can give any cell name and you can give attribute name, you will get the value of that. For example, if you want to set this attribute value to the different value, then you can use the set attribute. So if you use so you can use set attribute, you can use get cells, it is the same thing, and here you can give the attribute and you can change to the different value. So now what you are doing is you are just reading the attribute value of any attribute associated with the design object. Once you understood what is the value, then you can overwrite the things, you can just overwrite with the different value, and you can just use the set command. So the get command is used to read the value of the attribute, and the set command is used to set the attribute value of any attribute associated with the design object. We will be using very extensively in our classes actually, so you will become perfect, don't worry. Even I will make you to explain in the real-time design actually, so that parallel you will also do right along with me, so that you will clearly understand. So I will give you a script. I will tell you how to, means what is the script we need to write. Just I will tell you, explain you the algorithm. Just you need to just, even I will tell the fundamentals, like how to get the attributes, how to set the attributes, how to get the design object, and how to get the design attributes, and all those stuff. Once I will make you perfect, so that while writing the script, right, you will execute those commands in the tool, and you will only come up with the right command, and you will put in your script. I will definitely make you that one actually. So yeah, you know, right, here we can get the attributes, and even we can set the attributes to the different one. So this is another thing actually. So if you want, there is another thing called the report attributes. So if you have any net, right, if you want all the detailed information, the report attribute is for the detailed information. It is like queuing. So when you just click on any net, and your net will come, and if you do the queue, right, in the right side you might have known actually, you will get a lot of detailed the attribute information will come, right. So if you want the detailed information of any net, right, you can use the report attribute. There what it does is, it will take the net one, which is basically a design object, and in the left side it will give all the attributes, in the right side it will give all the values set. It is a very detailed thing actually. So just actually here, just I would like to segregate our entire Tcl course in the three parts actually. One is we will extensively work on the basic thing, and we will extensively work on the procedural aspects, and we will be extensively work on uh, on the collections, design objects, attribute, and all those stuff. So first, like in like total it will be like 12 sessions, right? So first, like the 5 sessions, hopefully the 5 or 6 sessions, like I will be working on I will show you, I will just explain you in detail like the different aspects. In the last 6 sessions, right, just we can only write only the scripts. Once you understand all the basic fundamentals, right, the last 6 weeks, just daily we can write a lot of scripts, so that when you, one is the learning the fundamentals and the application. Once you learn the things, right, so you're, while writing the scripting only, your application capability will come to foreground. So that's why first in the 5 to 6 sessions, right, I will clearly explain all the Tcl constructs and everything. In the last 6 weeks, right, it's just a scripting practice actually. We can take a random scripting application, just we can keep on writing the things. So here the important aspect is, I don't know here I know, right, here actually I have explained it. There are 3 kinds of command. One is the generic commands, and another is tool specific commands, another is the user defined commands. So but to write any script, right, you write any script, right, one is, what are the things we need to know? We need to know the syntax actually, that one actually we will understand. Another is we should be very familiar with the tool specific commands. So here I don't know, here many people they might have come with the PV background, timing background, implementation background, and some students actually they are from Innovus background. Here actually what we need to do means, even if you take my case, right, I work usually on the EMIR and the integrity and all those stuff. So here actually we are from the different background, but while writing the script, right, we can write, I can write any script on the PV, but the problem is, like, the PV engineers, if they help it, even we can write a better script. Why means, whatever the tool specific commands, right, those engineers should be knowing better, because if you take any, the timing will have like thousands of commands. The PT will have thousands of commands. So the important thing is, first we should be good at syntax, and we should know, if we are working on the timing related automation, right, at least first we need to explore what are the different types of different types of timing related commands are there. This is basically tool specific commands. Once we get familiarized with these tool specific commands, right, then it will be very easy to write the script actually. That is the thing. Hope actually, based on your domain, right, you have some exposure to the tool specific commands. If you take the timing, floor plan placement, CTS, or whatever. So if here actually our focus is not to explore the tool, but to just automate the tool. So it can be any tool. So if you're from the PV background, just what you can do is, you can come up with your own automation puzzle, or whatever you want to do, whatever the automate you want to do. But you can't tell me that actually I have to means I have to write the script, but I will definitely help you to write the script, provided you have to help me in the tool specific commands, because I am not from the PV background, right? Because that's why, if you, let us consider you want to work on some antenna related aspects, but if you know all the antenna related commands, right, then I can definitely help you to write the script to do more automation on those kind of stuff. Some guy can come with the synthesis background, so you want to do some automation kind of stuff, but here's the concept, and also you know what are the commands you need to use, the tool specific commands. So definitely I will help you how to do the automation for those stuff. So some guy will come from Innovus background, some guy will come from Red Dog background. So here there are a lot of tools are there, right? Only I will expect, like, on what are the things you have to decide, like what are the kind of automation I have to do, and I will tell you how to write the Tcl script very effectively. But you have to be good at exploring the tool specific commands, because there are a lot of domains are there, right? We are fitting in this course in all the domains. That's why if you help in getting the tool specific commands, right, it will be very effective. Did you understand my point? But I am good at, like, most of the domains, like I can also pick the tool specific commands, that is fine. But on the top of that, if you're interested in any specific kind of automation, right, so definitely you have to give the tool specific command information, like what are the commands you are planning to integrate in that script. That is the most important thing. It is not like I can take any random command I can fit in, but you are the end user, right? So that's why you need to explore the tool commands, and writing the codes, procedures, and those kind of stuff we can take care. That is fine actually. Okay, now I will give you some of the scripts actually you will be writing there, like the script to get instance pin, and slowly we will make the things complex. Like to get the logic level for 100 failing timing path, to get all the syncs for any specific clock. I have some set of applications just will be, and also the script to find out fan out of a specific net, and the script to find all the macros in the design along with the pin names, like that actually. And also to get the gate count in the entire design. To find the gate count, what we need to do, we need to add the areas of all the cells in the design, and we have to divide that area by the 2 input NAND gate, right? Like that we have to get the gate count. Like we can write lot of scripts actually. I will be helping you writing lot of scripts. and even you can come up with your own ideas also. We can just implement, provided that if you want to work on any specific things, right? But you should know what are the commands you need to use, means the tool specific commands, because you are expert in those kind of stuff, right? So that is the thing we will expect. And definitely once we start writing the script, right, you will get the confidence, and I'm very hopeful that you can write your own script in a very better way. Yeah, and these are the some of the things I would have in the thing. So coming to the execution of the script, right? So we'll be working on Orca top design, basically on ICC 2 shell. This training is not generic actually. It is, we will take one design and we will be doing some. We will write lot of scripts. We will write lot of scripts on this design. So all the scripts we will execute in the ICC 2 shell. Yeah, either anything actually, it remains same. Either you go to PT, DFT compiler, or the pattern will remain the same, but just we are just orienting, means just we are executing most of the command in ICC2 shell. So based on your requirement, definitely I can help. I don't know, the people, some people might have come from DFT background, PV background, timing, implementation. I don't know actually. Here there is a good crowd, and I don't know, the people are from the different background. Okay, the people are from the different background. Just if you come up with your ideas and you know the tool specific commands, right, then definitely we can write a very good scripts. On the top of that, even I'm good at some of the domain there actually. Even I can pick the right commands and help you, no issues, wherever I'm good, because there are a lot of domains, right? So even it is like the see, to write the script, right, the two aspects are important thing. One is the logic, another is the syntax. Three important things: the logic, syntax, and also how to implement that. Means you need the tool specific commands. The logic and the tool specific commands, like you should know, means how to implement that. Means there actually the syntax is not required. It is just an idea. Okay, we have to do like this, we have to do like this, we have to do like this. Then how to implement that I can really help you to do a very good scripts. So yeah.
Basically, hello.
Yeah,
Uh,
yeah.
thing is, what I want, I do not know about others and things like application oriented. I do not know much about it because I'm just new in the industry. But what how to build that logic actually. Basic is logic. When you can build your own logic about particular thing, then you can write a script by your own if you know the syntax. But the thing is that you must come with the idea that this must be in this way to get this particular output. So actually that what I need to practice here.
See, yeah,
What is
I
my
got your question. Yeah, here actually coming to the idea, right? Actually, I work extensively on the synthesis. I work on timing. I work on implementation. I work on EM, IR. So definitely, I will be having good idea actually. If even if you tell any issue, right? Definitely, I can explain you and I can tell you the idea. But let us consider actually there are some students from the PV and other stuff. So what happens is there my exposure is very less, right? During that time actually, just if I get some idea from them, right, so it will be very easy for me to write the thing actually. So if you're from, let us consider, most of the time the people feel difficulty in implementing the things. They will be having idea. Let us consider actually, okay, let us consider, if you take one simple example, right, you have to find here, just I will tell you one example, the script to find the logic levels of 100 failure timing path. Here you want the, what is the script output? You want to get the 100 failure timing path logic levels. So here what, just I will just convert it into idea. Let us consider this is a script. Okay, this is one script actually. So here, can anyone tell what is the output actually here? What we are trying to do here? We want to get the timing path, something like this. The output of the script should be like this. The timing path, like it can be start point and timing path start point and timing path end point, and we have to get number of logic levels. So we have to get this information for 100 failure paths. So here you got right, like this is the output we are expecting. Can anyone tell like what is the idea actually? So first everyone understood. First you have to everyone understood what is the output of the script. Let us how what is the idea, how to implement, I will explain. So first everyone understood what we have to write. We have to write a script to find 100 failing timing path, 100 failing timing path, and for those timing path, right, we have to find how many logic levels are there, means between means for any timing path it can be 6, 10, 11, anything. So the output will be like this actually. We have to get the timing start point, we have to get the timing end point, and we have to get the number of logic levels. Like that for 100 paths we have to get. So can anyone tell like how we can implement this idea?
First, we have to get how many timing paths in the design, and then from these timing paths, we have to get the failing timing paths. From that failing timing paths, we have to get only 100 failing timing paths, and that then from that we have to get the logic level of that failing particular uh, failing timing paths का logic level हमें पता करना पड़ेगा.
Correct. You told right. First, we have to get the number of timing path in the design. Then we have to get the timing path, means the 100 timing paths actually, 100 failing timing paths.
Failing points, huh?
So 100, and finally we have to get the logic. So you are splitting this puzzle, right? This is the idea I want. So everyone will come. Everyone knows the idea how to do that. The real problem comes with how to execute this. How to implement in a realistic Tcl script. That I will help. You got it right. The idea is very simple. See, but here the question is like I can't tell you like first you have to get these like you have to get the timing paths like this, then you have to get the 100 fail. Everyone knows actually when you understand the problem, when you understand any applications, right, you will clearly get the idea. Okay, first I have to do that, next I have to do that, then next I have to do that, then finally I have to reach this point. But the real problems comes in how to execute, means how to execute in the form of code to get this. That is the 99% effort we have to do. But what I will expect is I will expect the idea from you guys, but the implementation, right, I will help you. Implementation I will help you. But even if I give the idea and if I write it, it is like I have entire thing actually. I means even though if you don't have any idea, right, then actually I am writing the worksheet. It is something like that. Now the question is coming to the implementation. Just I will give some of the things. So here, if you want to get if you want to get the just do report timing, right, you will get one of the worst slack act, means one timing report. So if you want to get if you want to get the top 100 failure paths, right, you have to use minus max path 100. You have to use so if when you use the report timing minus max path 100, right, then the tool will report 100 the tool will report 100 worst of failure paths actually, means it will give the top 100 violators. It will give the complete detailed report. So in the detailed report we have to grep, we have to systematically use the regular expression command, and we have to grep, and we have to find the number of logic levels, and we have to do the proper reporting. It is like 30 to 40 lines of code actually. We have to do like that. So here my only means what I'm giving means first if you come up with the idea, right, then slowly step by step, first how to get the timing path in the design, we can find out the time, we can find out the right command, then we have to find how many, means how to get the 100 failure path, we can find the right command, how to do that actually. So like this actually definitely will help you, since it is a timing and those kind of stuff, right. I'm good at these kind of things. Even I can tell you idea and I can help you to implement, but I don't know from which background the people are from actually. So based on their requirement, right, so if there is a domain, because this is I'm not only concentrating on any specific tool, right. So if there is any student who comes from a very different, he can be working on some different hardware, he's from embedded system background, so during that time So if you tell me the idea, and if you just tell me the idea, right, it will be easy for them to help in implementation. But if anyone is from the VLSI background, most of the time I will be I have some decent knowledge in most of the areas, so I can help you in even writing, getting the ideas. I think,
Sir, one more thing. During implementation, like we have to first dump this report timing collection in some file, and then read from the file with the help of regular expression, like what will be the logic levels. Am I right?
correct. Like that we will do actually. Whatever you told, right? That
But
is the implementation. First,
yes,
we have to we have to put it in a file, and we have to read that file, and we have to grab the things, and again we have to put it in. Those kind of stuff will be working actually.
yeah, that's what I want to learn. Ki how to get particular thing from the file. That's why I mentioned about file handling first of all,
Yeah.
regular
Actually,
expression.
you told, right, everything I will explain, but if you get this information, right, remaining thing and all, I will help you how to write effectively.
Okay.
But do you think that you will get you can get this idea initially?
Yes, I can get this
Yeah,
idea.
but but the implementation, right? If you get, I am talking about only these things. If you are telling, right, first we have to get the report timing, and we have to put it in a file, and we have to read the file, and we have to take the logic level information, and we have to put it in a file. These kind of knowledge, if you have, right, idea, like every step that one I will help. Don't worry, actually. But
Yeah,
you
that
should break, you should come up with the idea, and you should have the multiple steps in mind. Then how to implement that one, maybe that is the main task of me actually, to help you to in the implementation phase.
okay.
Did you get my point?
Yeah,
Yeah,
basically
yeah.
we
And
require
yeah,
what
file
I huh?
file handler is the most important thing. I would cover in very detailed fashion, so I
And
will
regular
explain.
expressions, like regular expressions are very short and handy types of things. If you know how to implement the regular expressions, then you can just do quickly whatever you want from the file actually. So
Yeah,
what that I want to learn actually.
correct. Here, actually, the file handler and the regular expressions are the most important concept. We will be working on those things, because without regular expressions, we can't implement any script actually. So the script is all about regular expressions, file handlers, and procedures, and also the filtering applications, design objects, attributes. Only these are the main entities actually. If you're good at each thing, right, you can write your own script.
Yeah, and one more thing, like we have CSV file, some type of CSV file. Then how to take out data from that file in some array manner or in some list manner. That also I want to explore. Actually, I do have some idea, but I'm not good on it actually. I have idea, but I cannot do it by my own actually. That's why I'm taking this class.
Yeah. Here actually you have to understand two aspects actually. One is Tcl and another is the Perl. If you are only interested in doing the file processing, right, only means you are not taking any tool, but you have some CSV file dumped in one of the file, and you want to do the processing. But the Perl is a very good scripting language, but the Tcl is a very good scripting language if you want to take the information of the tool, and if you want to process, and if you want to read anything, right? So means if you want any, like, very if you want the well prepared information, right, from the tool, right, the Tcl is a very handy actually. So if you just tell me the application, right, based on that we can pick which language you want to write, and I can help you, no issues.
Yeah, one more thing. If you discussed about Perl, then will you explain more between Tickle and Perl? Actually, if I could learn Tickle, then
Mhm.
uh, will I be able to learn Perl also? Because these two languages are very useful in this industry. What I came to know and what I have to learn. Perl, I also want to learn. this is this is my next task actually. First Tickle.
No, actually the Tcl and the Perl actually both has its own capabilities actually. So wherever you can't intermix, actually wherever you have to use Perl, if you use the Perl in that, right, that will be useful. See, why the Tcl is useful means the tick, if you want to interact with any tool, right, always you have to, you can't interact, you can't interact with the tool. For example, take ICC2. you can't interact with the tool using the Perl. Always you have to interact with the ICC2 with Tcl only, right?
Okay, okay. Like if I want to use tool command itself in writing some script, then Tcl is helpful. And what about Perl? A
Correct,
simple
correct. Means,
file handler.
yeah. See here actually what happens is here tool, right? If you take tool, if you want to interact with the tool, it is you have to use Tcl and take whatever the relevant information you want, right? All the info you take from the tool. Once you get all the relevant information, right, you can do the processing using Perl. Actually, you can do the processing using Perl. So even you can call the Perl script inside the Tcl. If you want, I can help you
So
that way also.
a little bit more, which type of processing like?
Yeah, for example, actually most of the time we don't use Perl. For example, let us consider you want some data, you took some data, you did some report timing, you got all the Slack information and something like that, and you got all the information in a file. Now you want to put that file in a Excel as something like that, then you can make use of the Perl actually rather than Tcl.
Sorry, I couldn't get it actually.
See, usually, see, Perl is mainly for the text processing. For example, you got all the Slack. For example, you want some 100 worst Slack in a design. Let us consider.
Yeah.
So you get using the report timing, and if you do some file handling operation and the regular expression operation, you will get all the worst 100 Slack for 100 Slack information. 100 Slack information from the tool, and you have all the information in the file. Now if you want to process anything right from that file, then the Perl is a very good tool. Did you get my point?
Yeah, I get it, but like I know I was actually trying to learn from Google, so I know I have some idea about this. So, sir,
Okay,
like
maybe
which?
I don't know. Maybe if you I can share you my phone number. Maybe we can talk offline actually, because just we're
Thank you.
deviating here. We
Yeah,
are not discussing too much of the Perl related stuff actually. Only we'll be working on the Tcl because there are a lot of aspects. The Perl is another different area actually. Mainly the Perl means actually it's a uh, if you want to do especially the file processing, right? The Perl is very useful actually. Means that is the main important thing. So maybe we can take offline if you have. Maybe if you tell your idea, right? Means if you want to implement anything, right? If you tell me, so that if you tell me the scenario, I can tell actually how to implement that.
yeah. Please share your number.
Okay, okay,
Right.
okay. Thank you. Anyone has any
Thank you.
other questions before we close?
Hello. Hello.
Yeah. Actually, someone has used actually. Even we can use the slack lesser than 0 actually for all failing points. Yeah, you are right. Actually, Yogi has mentioned that we have to use slack lesser than 0. Yeah, it's right. Actually, if you want all the negative slack, right, we can use those switches. Just I'm giving some example. Apart from max path, right? Even if you use the slack lesser than 0, it will be very effective. Yeah, you're right, Yogi.
Hello, sir.
Any other questions? Yeah, we will take some applications and we will work, right? So definitely we will use the right switches just to give some information, right? Just I've told. So anyone has any other questions? Just I will anyhow you will get my phone number from the institute, or I can share you in the group. If anyone has any concerns, right, they can talk to me personally. That is also fine actually.
Hello, sir.
Yeah.
During the course of time, are we getting any access to tools, sir?
Yeah. Just talk to Srinivas. You will get VPN. Yeah, talk to Srinivas. You will get VPN access to the tool. You can use the tool. You will use the tool access.
Okay.
Yeah, and another thing is some people they want to mix Perl and the Tcl. Just I can give you some overview of the Perl, and Perl is another thing actually. Here 6 weeks is a very short time to implement the things in only the Tcl. I don't want to even take the Perl, and I don't want to deviate from the main thing. Here actually the people who want to do the tool automation, right? So Tcl is a very good command. Here we are sticking only to the Tcl actually. Here we are not taking any Perl, and there is a separate course for the Perl in the institute. I guess maybe if anyone has any